Welcome back, my wonderful PreAP chemistry kiddos. We're talking about chemical reactions, and we're building up to both writing and balancing and ultimately predicting chemical reactions. So let's look at a few more things that we need to be able to wrap our minds around if we're going to write a complete balanced equation. And that's the types of symbols that are used to represent what's happening in that test tube or that beaker. So let's take a look at this. We've got writing and balancing chemical arrows. The total number of atoms on one side will always be equal to the total number of atoms on the others. This is called balancing, and I've mentioned it already. It's so we don't violate the law of conservation of mass by implying, first off, we have different number of atoms, that we've created or destroyed number of atoms, and then ultimately, as we talk about the big picture, that we have the same number of mass on one side as we have on another. Now, some of the symbols that we're going to see is we're going to have reactants on the left. Always, whatever is on the left is considered reactants, going to products. Now, going to is really a better word for chemistry, is yields or forms or produces. There's a lot of different terms that'll be used, but I think you'll understand them in the context. Now, for now, we're going to talk about a single arrow, and then later on in the year, we'll see reactions that are reversible. And for reversible, we're going to use a double arrow, much like that. Often it's half arrows on top and on bottom. Now, when we're adding things together, we use a plus. There's no minus signs. Okay, it's always A plus B goes to C plus D, okay? If you have a pure substance all by itself, so if you have an element or if you have a neutral formula like NaCl or CH4, you're not going to see any charges, all right? If there's an ion, then we'll write charges, okay? Be careful, watch out for those diatomics: iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. Some people like I bring clay for our new house, or I also talked about Brinkelhoff. Those will come back a lot, as will continual knowledge of your polyatomic ions. You'll need to write an arrow sign, not an equals. It serves as an equals or produces, but don't write that in your balanced equation. Okay, write your correct formulas, put the plus sign between them, and here's a key point here. You want to make sure, let me get this up a little higher, and let's have a full discussion of this. You will often be required to write the states down. And you are at a point where we expect you to be able to figure out the states of some of our most basic substances, our most foundational substances. If you have a solid, we use an S, and usually it's superscripted, or italicized, not superscripted, but italicized. So if it says the word crystal or reference a precipitate, or if it's an ionic substance or pure metal, so ionics like sodium chloride. Always, when you think ionic, if you think about, whoops, I missed my S in there. If you think of sodium chloride as kind of the penultimate example of an ionic substance, that can often get you into some of the properties we're talking about, that it's crystalline, for example, and that it's a solid. Pure metals are solids with the exception of mercury. At room temperature, mercury is a liquid. Okay. Gases. All right, most of the gases you should be familiar with: methane gas, carbon dioxide gas, hydrogen gas. Our diatomics: iodine's a solid, bromine's a liquid. Our other diatomics are gases at room temperature. Okay, we use L if it's a pure liquid, not dissolved in water, a pure liquid. Aqueous means dissolved in water. AQ for aqua, so dissolved in water. And we'll often know that it's dissolved in water or aqueous because it will say solution of, or it will be an acid. Do you remember when we asked you to name acids, we would give you that AQ so you would know whether to name it according to the gas rules or the AQ rules. Okay? Single elements are often shown on the periodic table, if you can see the periodic table, but you really do need to get your mind wrapped around some of those so it's handier in your brain and you're not hunting it down. And then for many of the solids, we'll be able to use solubility rules. Okay? Now, when we're balancing, I've already mentioned this, don't change those subscripts that talk about bonding, that indicate bonding. And when you're balancing, you really want to go, what I like to do is I like to leave elements that are all by themselves for last, diatomics for second to last, all right? Now, if you have a polyatomic that stays together on both sides, all right, like let's, say I have lithium nitrate on one side and calcium nitrate on the other side, do you notice that that diatomic was not taken apart at all? I can treat it as a whole unit, and I could have just put a 2 in front there instead of counting the nitrogens and oxygens separately. So that's a handy hint as well. So let's take a look at actually doing some balancing. I'm going to do a little bit in the context of this because we're going to be writing some reactions and formulas, and then we will be doing some in class. But I am going to assume that you get this pretty quickly because that's been our experience. And if you're not, that means that you want to pull me over right away in class or even come to a tutorial so that we can help you better. So let's parse out this phrase here. I have a solid piece of zinc. So my symbol for zinc is Zn. You might want to refresh your memory on those. And it said solid piece, so I'm going to put a little S there. Reacts with means I'm going to put a plus. Hydrochloric acid, hydroic came from ide, so that meant chloride. So that means I have HCl, and since it's an acid, I have to put an AQ. The word produces tells me to put an arrow. Now I have zinc chloride. Zinc is +2, chloride's -1. And since it said solution of, I'm going to put an AQ. And, that word and tells me to put a plus sign there. Hydrogen gas. Hydrogen's a diatomic. Don't forget to write it as H2. On the top of your quizzes and tests, I'd suggest slamming down those diatomics and doing a double check before you finish any reaction. So I'm partway there. I have my formulas written out, but it's not balanced because I have differing numbers of elements on both sides. I have 1 hydrogen on this side and 2 hydrogens on that side, 1 chlorine on this side, 2 on that side. I'm going to leave my zinc for last, then I'm going to leave my diatomic for second to the last because putting numbers in front of those doesn't impact anything, any other element. So I'm going to start with my chlorine. I've got 1 here and 2 here. So if I put a 2 in front, remember you can't change the subscripts. You can only change those coefficients. So I'm going to put a 2 there. Sorry, I messed that up. A 2, and that means I've got 2 chlorines in my HCl. All right? So now I have 2 hydrogens and 2 hydrogens and 1 zinc and 1 zinc. So that's actually balanced. Some of you might like to write underneath what you have, and that's fine. That really helps a lot of people out, and then you cancel them. All right, phosphoric acid. I'm assuming you can figure out that phosphoric acid is H3PO4 and it's aqueous. A solution of sodium hydroxide. It said solution of, so I know that's aqueous. To produce, okay, so that's my arrow. A solution of, so I've got sodium phosphate. And since it said solution of, I know that's aqueous. And water. For water, we always put water as pure liquid. It doesn't make sense to have aqueous water because that's water dissolved in water, and that's not very logical. Okay? Now, Before we leave this, we need to balance the equation. It's kind of irrelevant where you start at this point. It's trial and error. But one thing that you can notice is I've got phosphate on this side and phosphate on that side. The polyatomic ion didn't change, and that may or may not help us, all right? I'm going to start with my sodium just because it jumps out at me. You could certainly start with your hydrogens, but because hydrogen shows up in two places, it makes it a little awkward to do. So I'm going to start with my sodiums. I have 3 sodiums there. I can't change the subscripts, but I can change the coefficient, the number in front, so I put a 3 there. All right? Now, that means I've got 1 phosphate and 1 phosphate. I've got 3 sodiums on both sides. Mimio's jumping a little bit on me again. 3 sodiums on both sides. So now let's count the hydrogens or the oxygens. I did not mean to do that. Shoot. I'm going to draw that real quick again. Phosphoric acid. I had 3 sodium hydroxides when we left. I don't know why Mimio does this to me. I hope you guys are patient with me on that. I'll probably have to get another new board one of these days. And then I have sodium phosphate, and that was aqueous, and then I had water. Now, let's count our hydrogens. I have 3 hydrogens here plus 3 hydrogens there. So I have 6 hydrogens. In order to balance my hydrogens out, in this case, I need a 3 in front. Okay? And that would balance that one. Chlorine gas. Don't forget chlorine's diatomic, so I need a 2 there. Gas is bubble through a solution of. So lithium iodide, since it said solution of, I'm going to put an AQ. The products are found to be lithium chloride, and again it said aqueous and solid iodine. Okay, so that's my reaction. To me, I can see it pretty quickly. Some of you may not be at that stage yet. 1 lithium and 1 lithium. I've got 2 chlorines, so I'm going to put a 2 here. Now I've got 2 lithiums, notice, right? And I've got 2 iodines. So if I put a 2 here, that gives me 2 lithiums and 2 iodines. 2 lithiums and 2 chlorines. So I have 2 of everything once I have done that. So let's go on to another couple of these. Just one more. Let's do this silver nitrate one. Okay. So solutions of silver nitrate. Remember the little joke? Hey, you got any gold? Ah, gee, all I have is silver. Because a lot of people mess up silver and gold. Reminds me of Rudolph, silver and gold. I'm not going to sing for you. You will be glad I didn't. Okay, notice that it said both of them are solutions, so I'm going to put an aqueous. Now, it says a precipitate of silver chloride is formed. Precipitate is the solid that is formed when 2 aqueous solutions are reacted together. And then it said a solution of barium nitrate, so that would be aqueous. So you see hopefully how you got the states out of the words there. That gave us what states to have. So now let's balance this. All right, nitrate didn't change in going from reactant to product. And I have 2 nitrates, and if I put a 2 in front of here, that'll give me 2 nitrates on this side. All right, now I have 2 silvers and 1 silver on that side, so I'm going to put a 2 in front of it. That gives me 2 silvers and 2 chlorides. I have 2 chlorides there. I have 1 barium and 1 barium. Everything's balanced. I've got 2 of everything. Now remember, don't change the subscripts, just the coefficients. All right, till we're working on this in class, this is your beloved chemistry teacher. Love you guys.